Did you know that you could unknowingly be using enough water on your mine site to fill 500 Olympic-sized swimming pools? I'm going to explain where. One of the most common types of pumps used on a processing plant. This is a picture of a Slurry Pro pump, but for the purpose of the argument, it doesn't necessarily matter what type of slurry pump it is. This is on a mineral sands site here in South Australia. A slurry pump is designed to pump slurries. So it has sacrificial liners that are easily repairable. Slurries, as we know, are abrasive. So to be able to quickly and efficiently repair the pump is a must. So these pumps, as with most centrifugal pumps, they have a drive shaft. So it's a shaft that is driven by an engine or electric motor, and that shaft penetrates through into the wet area of the pump, into the pump casing. And the impeller is screwed directly onto this shaft. So there's a requirement to seal the product that you're pumping with the outside area. So we do this for several ways. The most common way is using this. It's a piece of rope, also known as packing, and it forms a gland, commonly referred to as gland packing. You might say, well, why do we use this? It's the most cost-effective means of sealing a slurry pump. So for a new mine starting up, lower capital cost. I see it specified all the time. It's a very cheap sealing arrangement. These rings of gland packing are stuffed into the box, also called a stuffing box. And it's followed up by a plate called a gland plate or a gland follower. And this is the fully assembled gland assembly, tightly packed with gland packing. Gland packing is made typically from Teflon or graphite, so it's in some sense self-lubricating. But imagine what happens if slurry got under this rope. This rope is tightly packed and it's squeezing the shaft. If slurry were to get under it, you can imagine what would happen. Very quick early failure. So there is a need to introduce water to not only lubricate the gland packing, but also to expel the slurry out from this area. This water needs to be clean and free from contaminants. It can't be corrosive. You're dealing with metal parts. So you might be thinking at this point, oh, he's going to be talking about when this wears, water is going to be spewing out the back of the pump. And it's a common sight on a mine site. And operators might say, well, maintenance will fix that up in a couple of days. It'll be okay, it's only a few litres. But I'm not talking about what happens when it fails. I'm talking about general operation. So what you can see, what comes out the back of the pump during the pump operation is 1 drop per second. But there's a significant amount of water that actually goes into the pump. Now this is where it gets interesting. This is the real cost. So here we have a very small 1-inch slurry pump. One of the smallest slurry pumps. This slurry pump, when built with a packed gland, as I mentioned, is one of the most commonly forms of sealing arrangement, requires 15 litres per minute of water. You might say, well, okay, that doesn't sound like much, but per hour, that equates to 900 litres of water, or per day, nearly 22,000 litres of water, or per year, nearly 8 million litres of water this pump requires. Now I'm talking about one pump, and it's a very small 1-inch pump. You can see in the top left-hand corner there a picture of a 22,000 litre water truck. So that's how much water you are consuming in a day. This is how much water you're consuming in a year. Now, let's talk about a bigger pump, a 12-inch slurry pump. A 12-inch slurry pump in the same configuration requires 6,000 litres of water per hour, or 144,000 litres per day, or over 52 million litres of water per year out of one pump. You imagine a mine site. How many pumps are there on a mine site? Let's just pick a small mine here, so 45 pumps. You might say, well, my mine site has a lot more than that. But let's just run the numbers. The 10 smaller pumps are consuming 78 million litres of water annually. 25 medium-sized pumps, 434 million litres. And the 10 larger pumps, 525 million litres of water annually. This equates to over 1 billion litres of water annually that these pumps are consuming. Not only is it being consumed, but it's being fed into the slurry stream. So imagine you're pumping this water to the slurry pump to lubricate it. Then the slurry pump needs to pump that water away. That water then needs to be recycled or evaporated or whatever happens to it. So there's a lot of costs that are going into removing this water out of the slurry stream. So that's where Global Pumps, in cooperation with Sealtech in Italy, have developed a completely flushless mechanical sealing system for slurry pumps. So we're going from nearly over 1 billion litres of water annually to 0. Now this is a patent technology. The patent is in the shape of the seal faces. Now for those that are not sure what a mechanical seal is, you have two parts. One is fixed to the pump casing and the other is fixed to the shaft. And these two mating faces are highly polished and rotate against one another, and that performs the barrier between the pumped fluid and atmosphere. Now, the next secret behind this device is the fact that these two faces are diamond coated. So diamond, many may not know, has very interesting statistics. It has a very low coefficient of friction when it is running against itself. The diamond on diamond is generating the least amount of heat compared to other mechanical seal faces. It is also a very good conductor of heat. So any small amount of heat that it does generate, it can quickly dissipate it. So these two elements together result in a mechanical seal that does not require any lubrication water. So you do not require any infrastructure that surrounds water lubrication. That water is not being introduced into your slurry stream. Your slurry is not being diluted. Now you might say, well, diamond, that sounds expensive. Well, I'll tell you a funny story that happened recently. We had some of these faces being transported from the lab through to the seal manufacturing centre, and they went missing in transit. And going back through the con note, the description of the goods were diamond rings. So unfortunately, whoever took off with these diamond rings would not be getting the value out of them they thought they probably would have. But we're talking about a very small film on these seal faces, just a few micron. So it's not an expensive process. We've built a calculator, and here's an example of something we did for a client recently of what the return on investment would be should they replace their existing packed gland and retrofit it with our SealTech Flushless mechanical seal. And you can see the payback there is a 5,000% return on investment, payback period of 0.21 months. Not only that, not only the saving of money, but there's also the saving of labour. So back to the ESG consideration that we discussed earlier. And most of all, a saving of 17 million litres of water out of this particular size pump. So here is the example of where water is being consumed that may not be very well known in the mining industry, but there is a new technology that can do something about it. Thank you very much.